computer, you have a bad computer, doesn't matter according to second analysis. Some people are asking, sir, bad computer also, it is not depending on the right. Second one is not depending upon the bad computer also, good computer also. Then based on what criteria is giving? Remember everyone, right? His concentration is not good computer, not bad computer. His concentration is good logic. Good logic is not based on the good computer, bad computer. It is based on the good logic. Right? Second model concentration is logic only. Not the good processor, not the bad processor. Good logic are not that matter. If good logic, less time. Remember, total software industry is following second model only. Good logic, then less time. Good logic means less time. So everyone from today onwards, remember. Everyone from today onwards, you remember. See this one. Everyone from today onwards, remember. You have money or you don't have money, doesn't matter. You have money, you don't have money, doesn't matter. The thing which matters is brain. In your brain, good logic is there. Then you are going to reach the destination so easily. In your brain, bad logics are there. Definitely there is no use. I'm repeating once again. Money doesn't matter. Logics only matter. Good logics only matter. Those people who are running big companies. Money is not the reason why they are running big companies. The main reason why they are running big companies is good brain. Mukesh Ambani, good brain. So if you see the Anil Ambani, Mukesh Ambani, both are having same amount of money initially. Initially, they both are having same amount of money. But one person using brain, one person not using brain. Mukesh Ambani, Anil Ambani, initially both are having same money. Same amount of money they both are having. One is using the good logic, another one using the bad logic. Mukesh Ambani used good logics. Right? Good logic. Right? Means he used the brain efficiently. But maybe Anil Ambani not used. So what I mean to say is priori analysis saying that, right, language of the compiler doesn't matter. Type of hardware doesn't matter. Right? If you write the good logic, it will take less time. Right? Good logic, if you write, it is taking less time. Then that means, right, I think that is a better algorithm. Means better algorithm. Priori analysis is based on good logic. That is the reason total software industry follows this only. Total software industry follows this only. Writing good algorithm. If you have a good logic means good algorithm. Good logic means good algorithm. Total software industry follows good logic only. Right? Everyone may be having the good computer, may not having good computer. But remember everyone, if you have a good logic, even though you have waste computer, still you can manage. Try to understand. All the startup companies normally use, right, very bad computer. All the startup companies will use initial days very bad computer. They have worst computer. Every startup company initial days will use very bad computer. But still, some startups are made wonder. Some startups made wonder. How it is possible? Good logic. According to the first model, if you have a supercomputer, then only you can write the good algorithm. But second model is saying that even though you have a normal computer, still you can write the better algorithm. How? Just write the better logics. Just use the brain properly, then you can write the better algorithms. That's what you want to say. First analysis saying that supercomputer required. Second analysis saying that super brain required. First analysis saying that supercomputer required. Second analysis saying that superhuman required. If human is super, it doesn't matter what processor you have. Suppose isn't that you have a supercomputer, but human is not. Human is not using good logics. The human being who is using that computer is not using good logics. Even though you have faster computer, there is no use. Posterior analysis saying that supercomputer is there, I will write the super algorithm. But priori analysis saying that it doesn't matter what computer you have. If you have good logics, then you can construct the good algorithms. Total software industry follows priori analysis only. Okay, I think everyone is comfortable. Everyone is comfortable. Now I am discussing about priori analysis. Are you comfortable till here? Do you have any doubt? Do you have any doubt? To proceed further, do you have any doubt? To proceed further, do you have any doubt? Check everyone. Everyone try. So we are going to discuss now priori analysis. Priori analysis based on the logic. It is based on logic. It is based on logic. What exactly priori analysis? Within few minutes I will explain. It is based on logic. It is not based on the processor. It is not based on the language of compiler. It is based on the logic. So some people are asking, yeah, that's fine, sir. But can you say the definition? How? What way you will concentrate logic? What way you will take logic into consideration? So I am writing now. Remember, priori analysis means I am writing now. It is a determination of, this is the meaning of priori analysis. Priori analysis based on the logic. Okay, that's okay. But what is the meaning of logic, sir? See the logic? It is a determination of. It is a determination of order of magnitude. It is a determination of order of magnitude of a statement. This is the definition. It is a determination of order of magnitude of a statement. It is a determination of order of magnitude of a statement. This is the definition. It is a determination of order of magnitude of a statement. What exactly meaning? I will explain. What exactly meaning of the story? I am going to explain. Priori analysis is nothing but it is a determination of order of magnitude of a statement. Right? Fine. Perfect. So to get the clarity, can you take the first example? To get the clarity, can you take the first example? So remember, I am going to explain 30 examples. I am going to explain 30 examples. I am going to explain 30 examples. From now onwards, be careful. Time complexity finding. From now onwards, I am going to explain 30 examples. So be careful. Example 1. Example 1. Take the first example. Main x is equal to y plus z. Main x is equal to y plus z. Right. So can anyone help me now? This program time complexity I have to calculate. This program time complexity I have to calculate. I am calculating now. Those people who are watching, please say what is the time complexity. What you are thinking. What is the time complexity of this program? Can anyone say? Please let me know what the time complexity you are thinking. It is the first problem. I am going to explain 30 problem, which is going to be very, very important topic. Today's topic is very, very important one. Today's topic is very, very important one. Yeah, can me once say what is the time complexity of this program? You are thinking. Yeah, please give answer. What is the time complexity of this program? You are thinking. Try everyone. So in my opinion, today's class is just started now. Actually, this is my goal of today's class. This is the actually my goal of today's class. Time complexity of this program is how much? Yeah, I think Sunny is saying that 1. So let me check. Let me check this one. I'm giving the answer. Everyone listen. Everyone listen. Yeah, I will follow some color. Yeah, fine. That's okay. See this one. This program contain only one statement. This program contain only one statement. Everyone try to understand. This program contain only one statement. See, whenever this program is running, this statement will execute only one time. One statement is there, it's okay. This program contain one statement. I am okay with that. Whenever you are running this program, this statement will execute only one time. This statement will execute only one time, which is known as order of magnitude. Order of magnitude means whenever a program is running, a statement will execute how many times? Order of magnitude of a statement. Order of magnitude of a statement. What is the meaning? The meaning is whenever this program is running, the statement will execute how many times? One time. So just to find out order of magnitude. So only one statement is there. Find out order of magnitude. Whenever this program is running, the statement will execute one time, right? So after finding it, whatever answer you got, to that answer, you can write capital O of 1. To that particular one, you write to that particular number, whatever you got, you can write capital O of 1. You can write capital O of 1. You can write, right? You can write omega of 1 also. You can write theta of 1 also. All the three symbols you can use, but as of now, use only big O. Capital O means big O. You can use all the symbols. Anyhow, we will discuss those symbols afterwards. As of now, use only big O. Capital O is nothing but a big O. So the way of reading is big O. Big O of 1. Big O of 1. Just to find out how many statements are there. Every statement order of magnitude find out. Every statement order of magnitude find out. Okay, I think you are a little bit okay. I think you are a little bit okay. Can you go to next problem? Right, you will get in the next problem more clarity. Can you go there? Example 2. Example 2. Main. Example 2. Main x is equal to y plus z. Main x is equal to y plus z for I is equal to 1, I less than or equal to n, I plus plus. X is equal to y plus z. Now those people who are watching this class, please let me know this program contain how many statements. Those people who are watching this class, please let me know this second program contain how many statements. Please let me know. Yeah, let me give answer. Let me give answer, everyone. Everyone give the answer to me. See this? It is the first statement. Careful, everyone. It is the first statement. It is the second statement. This program contains two statements. Second program contains two statements. But remember everyone, whenever this program is running, careful everyone, whenever this program is running, first statement executing one time. Whenever this program is running, first statement executing one time, but the second statement executing n times. Whenever this program is running, right, first statement executing one time, second statement executing n times. You may say that some people are asking, sir, how can you say n times, sir? Can you see this? How can you say n times, sir? Reddy, sir, how can you confirm it is a n time? Let me check. How n times? Let's see this one. This is called initialization. This is called condition checking. I is equal to 1, I less than or equal to 1, so I value is 1. 1 less than or equal to n, condition true. For every true, execute this statement. After true, increment the value. Then I value becomes 2. Now 2 less than, right, afterwards it will come here. 2 less than or equal to n, condition true. Then execute the statement. Then again I plus plus, it became 3. 3 less than or equal to n, condition true. Then again execute the statement. So let me give the number. First E will execute. Next B will execute. Afterwards C will execute. Afterwards D will execute. Afterwards again B will execute. So because of colors are not visible, so I will use another color. You may get more clarity. Yeah, now see this one. This will execute first A, next B, next C, next D. This is the way how they will execute. Can you see this one? First A, next B, next C, next D, after D, B, after B, C, after C, D, after D, B. So I think remember B, C, D keep on rotating. Remember A will be one time only. This is called for loop. Loop means executing many times. So first statement will execute one time, second statement will execute n time. First statement will execute one time, second statement will execute n times. You may say that, sir, how n time? So one time will execute, second time will execute, third time will execute, fourth time will execute, continue. Nth time, n less than or equal to n, condition true, that is also executed. Afterwards, so I value becomes n plus 1. It is a keep on incrementing until n. After some point of time, it became n plus 1. It is also became n plus 1. N plus 1 less than or equal to n, condition fail. Whenever it is fail, it will come outside. So this statement will execute n time only. What I mean to say is, second program contains two statements. First statement executing one time. Second statement will execute n time. This is the order of magnitude of first statement. This is the order of magnitude of second statement. So if you add both the order of magnitude, if you add that n plus 1, remember in the n plus 1, whoever is the bigger one, who is the bigger? N. Whoever bigger, you keep capital O. That is the reason it is a big O of n. In the n plus 1, whoever bigger, you take it. That is the reason it is called big O of n. So the time complexity of this program is actually n plus 1. You can say big O of n also. Because priori analysis is approximate analysis. Plus 1, minus 1, don't bother. Priori analysis is approximate analysis. Plus 1, minus 1, don't bother. Actual time n plus 1. Right? Approximately, it is order of n. That is the meaning of big O. Big O notation, omega notation, theta notation. They are approximate analysis. N plus 1, you can write big O of n. N plus 1, you can write omega of n. N plus 1, you can write theta of n. What exactly difference between big O, omega, theta? Afterwards, I will explain. As of now, just concentrate big O. Very simple. N plus 1. Whoever bigger, you take. Just keep big O of N. So I think 2 programs we done. Time complexity finding. This is the very crucial part of algorithm subject. Algorithm subject crucial part is finding time complexity. So I think Sunny is saying that ABD, not statements. I think Sunny is a very good question. The question what you asked is very good. Within few minutes you will get more clarity. Please remember your doubt. Please remember your doubt. Within few minutes you will get more clarity. Thank you so much for asking the doubt. It's a very good doubt. Within few minutes you will get the answer. As of now, this program time complexity big O of N. Actually N plus 1. Actually N plus 1. Right? Which can be written as big O of N. Means approximately N. Forget about small numbers. Plus 1. Forget about small number. Yeah, Sunny asked one nice doubt. Sunny asked one nice doubt. I am going to explain in further problems. Now go to example 3. Go to example 3. Right, write down now. Main. Example 3. Main. X is equal to y plus z. X is equal to y plus z. For I is equal to 1, I less than or equal to n, I plus plus, x is equal to y plus z. Next one, for I is equal to 1, I less than or equal to n, I plus plus, for j is equal to 1, j less than or equal to n, j plus plus, x is equal to y plus z. Yeah, my suggestion to everyone, please let me know in this program how many statements. My suggestion to everyone, please let me know in this program how many statements. Please let me know in this program how many statements. Everyone try. How many statements in this program? Yeah, 3 statements. This program contains 3 statements. Excellent. Excellent, Sunny. Sunny, thank you so much. Great cooperation, Sunny. So it is a number 1 statement. It is a number 2 statement. It is the number 3 statement. Remember, some people, you may ask that, sir, how can you say it is the second statement? What about for loop? Remember, that is a supporting character. To run this statement, that for loop is useful. For loop is not a statement. Inside for loop, there is a statement. This is the statement. This statement to run many times. It is doing some supporting. Some support it is doing. So in the similar way, in one house 5 people are there. If I ask how many people are there, say 5 people. Don't count. Pillars are there, bricks are there. Don't count all of them. In this house, how many people are there? Please say 5 people are there. In one house, 5 people are there. I am asking how many people. Say 5 people. Don't say pillars 25. Don't say bricks 1 lakh. Don't say cement 25 basta. Right? Please don't say this. Iron, right? 50 kg iron. Don't say like this. So these are supporting character. So remember, right? First statement. Second statement is executing many times. For supporting purpose, one for loop is there. Third statement also executing many times. For supporting purpose, so many statements are there. Now let's run this program. Whenever you are running this program, if you observe clearly, whenever you are running this program, if you observe clearly, first statement is executing one time. Second statement is executing n times. Third statement is executing n square time. Third statement executing n square time. So remember, this is called inner loop. This is called inner loop. These are called inner loop. Inside one for loop, one more for loop. In loop, one more for loop. They are called inner loops. Some people are asking, sir, how inner loop is running? Similar way, whatever way above one is running, same way this also. I am executing one time. Can you see this one? Can you see this one? Right? Initialization, condition checking. Remember, for every condition checking, you have to come to J loop. For every condition checking, you have to come to J loop. Now see the J loop. I is equal to one purpose, I came inside J loop. I is equal to one purpose, I came inside J loop. See how the J loop is going on. J is equal to 1, condition true, execute statement, then J plus plus, then J value becomes 2, 2 less than or equal to 1. Remember, J loop is going on. 1, 2, 3, and so on, n. J loop is n time. I value 1, J is n. Whenever J loop is completed, n time, right? Then J loop is fail. Then you will go to I plus plus. Then I value becomes 2. Whenever J loop is over, then J loop is fail. Then you will go to the outer loop. Outer loop is I. So I value becomes 2. Now again J value will start from 1. That is the meaning of inner loop. Next one, whenever J loop is over again I value becomes 3. J value becomes 1, 2, 3, and so on n. Whenever J loop is fail, I value becomes 4. J becomes once again 1, 2, 3, and so on n. So it will continue. Lastly, I value becomes n. J also becomes 1, 2, 3, and so on n. Whenever J fail, I will go to I also fail. Whenever J fail, I will go to the I became I plus 1, then I also fail. So what I mean to say is, I value 1, J loop is n time. I value 2, J loop is n time. Every time you are executing the statement. I value 3, J loop is n time. I value 4, J loop is n time. I value n, J loop is n time. Remember, n times n, totally n square. So second statement, right? Third statement executing n square time. First statement executing 1 time. Second statement executing n time. Third statement executing n square time. Total this program is executing. N square plus n plus 1. This is the actual time. N square plus n plus 1. This is the actual time complexity of this program. But remember, this analysis is the approximate analysis. N square, n plus 1, bigger one is n square. You can write big O of n square. The time complexity of this program is big O of n square. Whoever bigger you take. Remember, you may say that, sir, this program contains so many statements. How can you say only 3 statements? Remember that for loop is supporting character. It is a supporting. Otherwise, how can you execute one statement n times? How it is possible? Without those supporting character, how can you execute that one n time? They are supporting characters. Right? Fine. You may get more clarity. Sunny, you will get more clarity further. Now, time complexity of this program is order of n square. Are you comfortable or not? Please let me know. Sunny, are you comfortable or not? Please let me know. If those supporting characters are not there, how one statement will execute n time? If that supporting character is not there, how that statement will execute n square time? Are you getting? See this one. These supporting characters are not there. How you will execute n square time? This supporting character not there. how he will execute n time, right? So supporting character. If you say this person is executing n time, if the supporting people are not there, how he can? If pillars are not there, how building will be? If building is not there, then how, building is there, then only people will be there. So remember, number of people means number of people. Remaining people are supporting character. So second statement executing n time. How? With the help of for loop. Third statement executing n square times. How? With the help of two loops, two inner loops. This inner loop is n time. This inner loop is one more n time. N times n. Right? See, 1 times n, 2 times n, 2n, 3 times n, 3n, 4 times n, 4n, n times n, n square. N times n. N times n. Every time n, like that n time, n square. Finally, order of n square. So the time complexity of this program is order of n square. Remember everyone, this is the meaning of priori analysis. Priori analysis purpose is logic, right? These are the logic. Every loop is some logic is going on. Calculating the logics is called priori analysis. Priori analysis saying that a algorithm is good because of logics, not because of supercomputer. A program is right, someone is written the great program, not because of computer, because of his logics. Right? Fine. Right? I'm thinking everyone is comfortable.